there's the go live button. Okay, so. All right. All right, now let's just make sure that I've got the right window in the right place. Okay.
Is that an advertisement?
What the big poster? I think we're live. Can everybody hear us?
I'm hearing an advertisement.
You're hearing an ad? Oh, okay. I guess it's starting with an ad.
Slowing it down.
Okay. So. Okay. Eric's in to join us. So, there's my music. Let's may as well intro sequence.
How long is this commercial?
Oh, I don't know. You can hit skip. Let's just figure that out. Oh, I turn this back up. Can everybody hear me now? I think I turned the wrong thing down when I had the music up. So, can everybody hear me now?
I can hear you.
Okay, good. Well, you can hear me through Zoom. So I just want to make sure that the chat catches up. All right. Had sound with the intro music, but not with this. Uh-oh. Okay. Let's just make sure.
Guess what? What is yes?
So you can.
You're saying yes.
Okay. You can hear me now. Thumbs up. Good. All right. Okay. I had turned down the wrong slider in OBS. So my lips were flapping, but nothing was happening. So I just again. I want to go back and welcome everyone. Thank you all for joining us today and being a part of today's live stream. And this is a continuation of our live stream almost a month ago with David Bedard. And today's 3D printing. There is going to be a little some Q&A kind of on the fly, but this one is going to be more of a watch a work in progress kind of thing. And so I'm going to largely turn things over to Dave to kind of walk us through his process for actually creating something for 3D printing. And the goal is by the end of this show, we will actually have an STL file that you will be able to download for yourself. Dave, I think your Facebook group, you're going to post it there with your permission. I will post it to Thingiverse with proper credit and copyright things attached to it. And just so that it's available, because Dave, do you have a Thingiverse page of your own yet?
No.
Okay, So it's just a matter of making it available. Now, of course, this being a live stream, everything can kind of happen. My son just walked in. Love you too, Ian. And he just wandered on through. So anyway, I'm going to bring this over so that we can actually see Dave. So we have the way that we've arranged this. Last time I was very delayed, so I've done a little bit of changes with OBS so that you can actually see what Dave is doing, and with that, I actually think Dave. I'm going to get rid of as much as I like to show my own branding and things like that. I am actually going to hide that so that everybody has full access to what you're showing us. And hopefully that will give everybody kind of a free range to be able to zoom in and see what everybody's doing. We've got the chat open. This is as much a Q&A. So, David, what have you been printing?
Roundhouse bits.
Roundhouse bits. Okay.
It's massive.
Okay, and. Like you showed us, of course, the deck the last time we did this, right?
Yeah, can you see my screen or no?
I certainly can. Hope everybody else can.
Let's make sure people can see.
All right, just give a thumbs up or a yes if you can see what David is offering. He is currently working on. Well, you had showed us the deck, but this is the roundhouse that you're working on.
Yeah.
So, all right.
Can you see that? How is it? I'm going in and out. Is it?
Yeah, it's not too bad. It's a little choppy, but I think that's just normal for a live stream. Screen or a Zoom screen share being the case. Wow, that's a lot of parts.
It's a ton of parts, and they're bigger than you think.
Yeah,
this part here, it takes about 3 hours to print. This one about 5. The one in the back about 5.
Okay.
This shorter rear section is about 2.5, and these guys here are about 3 apiece, and these are about 6 apiece.
Okay.
You add them up. I believe I had it down to 103 hours. Like this wall is a 6-hour print.
Wow. And you're doing this all on your FDM printer as opposed to your resin printer.
Yeah, well, the resin printer gets to print stuff like this,
yes.
Right?
Okay.
Where you've got the little rivet detail with the hinges and the fine detail with the little stray piece of thing. Away. I did some testing, and I've decided to add an additional magnet hole.
Okay.
Rather than my typical 3, I've got a 4th one on the top.
Okay.
That'll help things along.
Okay. Why adding the 4th one at the top?
The resin bit this door seems to be a little heavier than the FDM printed one.
Okay.
So this will help it hang on the. You see the door frame here? It's got matching holes.
Right.
You can see that, okay?
Yeah, I can see it fine.
So, yeah, those are. I think I got them at 2.2 mil by 1.5 mil deep.
Okay.
That's to because when you print that out, it's going to become like a 2 millimeter hole. It's a bit smaller,
right?
And it's a bit shallower, so it fits the 2 mil by 1 mil magnet a little bit better than.
Yeah.
And when I print out the door, I actually print it out at 99%.
Okay, so
at 100%, there's actually expansion in the resin.
Okay.
And you can tell, the door is a little too big, but the holes just don't line up properly.
Okay.
And if you print it off at 98%, the door is too small, so 99 seems to be the sweet spot. Okay. But then I'm combining resin with FDM, right?
Yeah. So hypothetically, say for example, you had a printer large enough to actually print the whole thing in resin, which none of us do, I think, at this point in time. Some of us might. Would you just keep it all the same size, or would you still scale the doors down just a hair?
It depends on the part. Like, for example, my wings for the plows, I've got to scale them at 101%.
Okay.
To have the magnets match up to the plow front.
Okay.
So it's more trial and error.
Mm-hmm.
It also could do with the calibration with the FDM printer versus the SLA printer.
Yeah.
It might be a little bit different.
So how much of this do you have printed so far?
I've got all the rear walls, all the front doors, all the concrete floor bits. Mm-hmm. I don't have the back shop, which is this stuff here. Okay. I haven't printed that off yet. I need to expand my layout to accommodate this.
Okay.
But it's quite a bit. It's a big piece.
Yeah. Well, I noticed that you don't have the back shop piece sliced up yet. Are you you're gonna? I would imagine you would have to slice that off in order to get it to fit on the bed of the printer, as large as your FDM printer happens to be.
Well, yeah, I've got the actual plans for this.
Okay.
But I haven't got to the point where, like right now, it's just sans back shop, right? So once I get the Roundhouse installed with the turntable and the tracks in with all the electronics working, the back shop is an add-on. It's its own electrical block and its own, obviously, its own building. There'll be a connecting wall. This is a concrete wall that belongs to the Roundhouse, and then there'll be a matching wall with wood timbers and whatnot. Okay. For the actual back shop, right? Okay. So it's a different material in the real world then. Right. But yeah, this will be its own thing. So and this is more future stuff, but you can see how I can come in here, and if this side here is wider, I can there we go. Gotta catch up to my own thoughts. I can make it wider if I want, right? Okay, right. And just... so I'll make it to scale, but the scale's kind of like, is it really scale? Well, no, because these track centers are too far apart compared to the prototype. Right. And that's a product of my space. My space means that instead of being at 10 degrees, these stalls are at 15 degrees. Okay. Right? So when you look at, if you come off the turntable into one of these back tracks, the back shop leads, well, in the real life, they're closer together. They don't have to straighten out as much. But I've got 15 degrees of separation, and each one of them's got to move over 7.5 degrees. Okay. Which puts them farther apart. Right. There's a question that just came up on chat from eMachine898. Was just asking, you're using AutoCAD. Is it difficult to output to STL files? No, I'll show you. So let's say this base here for the back shop is all done. Yeah. So I go up to the top right corner. Can you see that? Yes. Okay, so make sure you can see that. And then there's this export tab. So you got save as, import, export, right? And then you go down to where it says other formats. And then you go, let's say I'm going to put it into turntable. I don't know if you can read that folder there, the turntable. Put it this way: if everybody puts us up to full screen, then they should be able to see it without too much trouble. Okay. And then I got another subfolder called floors, and let's call this back shop floor test. Right? I go save, and then I got to select what I want to save. Now, AutoCAD is waiting for a solid or water type mesh. Right. Let's select two of these, because there are actually two pieces, right? Right. Hit enter, right? And I can go in to say, let's go to Cura. Let's go to Cura here. So, if you can see the Cura opening up here. Yeah, I can see Cura opening up, and just to show that it actually went in there. So I need to go to turntable, floors, and this is what back shop. What do we call it? Back shop floor test. Yep. Open it. There it is. So I don't think that'll fit on the printer. Nope. But that shows how just how simple it is to export in. You obviously have to size it.
Just for the fun of it, would that actually scale that down to N scale, just right there, and see if it'll fit?
How do you scale here?
Scale and then just 54. Any axis, as long as they're linked together, 54.5%.
Yeah, that'll fit.
Yeah. Okay. So, but that also shows you how. I mean, there are some tweaks if you're converting between scales, but on the surface, this is actually a fairly easy way to do that. Curiously enough,
7 hours 15 minutes.
Mm-hmm.
7 hours 15 minutes.
Actually, that's not too bad.
No, and that's with 10% or 15% info.
Okay. And okay. So we got a hello from Lunenburg, Nova Scotia, from HSWR Railway. So my ancestral homeland, so it's good to see some folk from Nova Scotia. So anyway, Dave, I'm going to just do a very quick show and tell of a problem that I ran into between the last time we did this and now. That I've been working on just something simple. It's a paint rack. So just give me a moment here, and I'm just going to transition to this briefly. That I went to paint, or I went to print a paint rack that I had actually designed in SketchUp. I've been starting to use Fusion 360. I'm not proficient enough with it. But I made something to a universal paint rack that can hold multiple types of paint. Anyway, I designed the file, and then I went to print it, and I had a print failure because I literally ran out of filament partway through. It's like, oh great, because you can see here where the printing stopped. You can, if you look carefully, you can kind of see the rings in there that it's intended to hold multiple jar types. Anyway, a friend of mine said, well, why don't you just take the original model, sink it into it, just right in the slicing program, sink it down, measure how much actually printed, sink it down that much into the plate, and then print the rest of it. And guess what? I did just that, and it just fits perfectly. Now, if this was something more precision, well, this may not work, but I can actually use a little bit of, for PLA, you can use just MEK, methyl alpha ketone. The orange plaster solvent will actually work for gluing this, as I found. So, and that's kind of a handy little trick that I learned. Anyway, we came here to watch you work, David.
Oh, great!
And so partly you got something that you're currently working on, and then we're actually going to go into an actual design. And this, so the first part is just you're working on something, and tell us a bit about your process. And then the next part is, and fairly quickly, you're going to see how fast David can work. In terms,
well, I won't go. I'm not going to set any record.
No, I know, but I mean, you are I'm still barely learning how to use Fusion 360. I see that John Kalin is here, and he's saying that he's using Fusion 360. Which, if you're using it for personal, it is free, but you have to sign up and register it each year you use it. And Fusion 360 is by the same people who make AutoCAD. But it's very online dependent. So anyway, David, take it away. What are you working on?
Well, this might be really short because I can't find. Yeah, okay. So, where the heck did I go?
Is that it there?
No. I gotta find it.
Okay.
Is it in here maybe? No, it's never mind. Let's move on.
Okay. All right. Well,
it's not there. I should be looking at. There's a CPR eyebrow for an SD40.
Okay.
And you know what? I could probably just modify this one. Let's do that.
Well, so I think you were telling this before, that you were taking basically the eyebrow where the light boards are, and what are you doing to it?
I'm making the CN version.
Okay. And because we have people from all over. What is the difference between the CN and the CP version on the SD? And
there's a notch. There's a notch at the top of the like this one here on the right is the CPR light board, and this one here is CPR light board without the knobbies. But we're gonna fix that.
Okay.
I'm gonna minimize it. It's getting my way. Okay, slice.
Mm-hmm. So, and I will keep.
Feel free to
ask
any questions.
And as David is working on this, any questions that you have, please fire them off in chat. I do happen to have the super chat active, and I've got a little whistle here just in case. I don't do live streams enough to kind of expect that, but it is currently active, so there's a little bit of a blurb there. So I'm seeing a couple of different. Actually, here's a question I'm going to throw out to people while you're doing that, David. If you're working in a design program, what programs are you using? I'm just curious for everybody in chat. Just let us know. Do you use SketchUp, Fusion? Are you do you have access to AutoCAD in the same way that David does? Just let us know. I'm curious. I'm part of this is curiosity. Actually, while we're chatting, David, one of the insane ideas I have is that there are a number of foundries for 3D models out there, and a lot of them are designed specifically for things like video game 3D models, like any stuff that's supposed to remain in the digital field. But is it possible to actually take a model like that? Like, say for example, here's one insane idea that I've got is if you're doing, say, a port and you want to ship, to actually download one of these models and take some time to convert it into a functional STL, slice it up, because no matter what the scale is, it's going to be enormous, and print the thing out.
Is that a question?
Yeah, it's something I'm kind of tossing out, because honestly, it's something I'm thinking of doing.
Depends what format. What's going on here? The AutoCAD, because it likes a lot of memory, so it's slow when I'm streaming.
Yeah. Well, streaming does take up its own memory as well. So.
Yeah, it's okay. Depends what format you get it in, because that's a beast. Yes. If it's an STL, you're kind of out of luck. You've got to go to like a Fusion 360 to get that done.
Right.
Hey, look at that.
There we are. All done.
That's it.
Wow, that's it. That's.
Is that? No, it's the same piece. So what I'm going to do. Some of these had two classification lights, so I'm going to move this and this. We're going to move them up. No, dang, let's go solid slice. You'll notice when I'm working here, I like cutting things in half. And going like that.
Yeah, because it's a case of if you cut it in half, you get rid of the other half, you do the modifications, and then when you do the change, that means when you flip it over, it's completely symmetrical. Is that the idea?
So one thing I'm doing here is I'm using, because the face of this number board is askew to the actual plane. So I'm using AutoCAD to reference the face of this model, and now allows me to work directly on this face as if this were parallel to the rest of the model. Does that make sense? Right? So what I'm trying to do is I'm trying to slice off this classification light. And so I'm just slowly working my way down.
Mm-hmm.
That should be, all right. And then I'm going by memory here. I'm not a CN modeler. I think one gets pushed out. Let's go farther here. Let's
Okay.
go move. Ah, look at that. A little dimple came in. Let's get rid of him.
Okay.
And then there's a second one. I think it's halfway. I have to dig up a CN-SC40-2 picture. But the idea is now I've got the two classification lights.
Right.
Yeah, and then we can rebuild this. But I'm still askew, right? So I have to go to object and find something that's flat.
Right.
Let's go mirror. And then we're going to move this guy. I moved him up 50. Let's move him down 50. He should line up just where he was before. You can see that's the new version of that.
And there we go. Okay.
Yeah, that's it. And then I can come and I haven't been referencing photos with this, so I'm just going to pretend that it's done, and I want to get it printed, right? So we're going to call it CN test eyebrow and put 2 there because it's got the pair of classification lights.
Right.
Select all of them. And let's go into Tutu box. Oops, that was a mistake.
Right.
What mistake did I do there?
You didn't save it as an STL yet.
No, I just did.
Oh, okay.
It's the bell.
Oh.
The bell's got to be a separate piece.
Right, because otherwise it won't print properly.
It won't print properly.
Okay.
What do we call this? We have CN eyebrow test. Okay. Yeah, I'm going to replace it. It's got 9 pieces to it, but once we open up Tutu box, we open this up. Documents. CN open. There it is. This is what we just made.
All right.
Right now, in this orientation, it won't print well at all, right? Because you've got a big flat area.
Yep.
Right, and then 2 of these locator knobs. These match the cab, right? So it gets located properly. So the other one option is, well, let's change the orientation to this way, right? Well, the problem with that is now the bell mount won't print properly because it's a big old island. It's in the middle of nowhere.
Right.
Okay, so the next thing we're going to do is we're going to rotate it. Let's go 45 degrees. Okay, now we can see, because we want the model to build off of itself.
Yeah.
We got this edge here, right?
Yep.
So if we were to support the edge, and we have to support the 2 lower limits to these pegs, and then it should print okay. So let's go and print it up. I usually, what's going on here? 4 mil. It's usually a good place. So we got on the right hand side, we got light, medium, and heavy supports, and they're obviously all different. If you can use heavy, use heavy. I'm a heavy guy. Heavy's the way to go. But I'm going to apply these supports. I'm someone who likes things even. So I go, the middle one I put in the middle, and then I do that one halfway, this one halfway, this one halfway, 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 halfway. And then for the pegs, I'll move to a medium and just support the bottom end and support the bottom end. So let's look at what we've done here. Now, when these are cut off, we got little nubbies left over from the support. So you can just take a file and just run along once and it'll be gone. It'll be fixed. But this guy, the support in the front, he's like the odd man out, right? He's no good. And I really don't like this one because this one requires me filing the front of the number board, the side, and the bottom. I don't like him at all. So we're going to remove those guys. Click the remove tool, hit delete, go back to the add tool, and on those corners, instead of adding the heavy ones, we're going to add medium.
Okay.
Right, so go medium, medium. Now you can see on the corners, we've got support. However, yeah, this one's perfect. It's hard to get a really good angle, but there's no island here. This will print, the support will print before the part. And that's what you want. Let's look at the other side.
Yeah.
See, this one won't. This one's no good.
Right.
Because the leading edge of this number board is going to print before the supports. We need to get rid of him.
Okay.
And we need to bring that support as close to the bottom as we can. That's not bad.
Yeah.
So you can see the support will print before the part. And that's the trick. So once this bottom edge prints, the rest will follow suit. Now the problem is we've got lots of support in the front of the eyebrow, but near the top of it, there's nothing, right?
Yeah.
So we're going to add some auxiliary supports. You know, one here and one here, maybe one there. And that'll keep it upright.
Now,
you can add as many as you like, but the idea is keeping this from flopping around.
Right.
And at this point, that's enough supports. Well, this will print just fine.
Okay. And those are heavy supports.
Yeah, most of them are heavy. You can see the thickies, and then you've got some of the medium ones.
Yeah. Do you ever? How much of the light ones do you do, or do you tend to stick with?
Never.
Okay.
I never use them.
Okay.
Depending on the resin. If I was using an elegoo black resin, we talked about the scale last week about one side being super highly detailed but brittle, and the other side being very little detail but flexible, right? Well, the elegoo black resin is way over towards the side of lots of detailed brittle.
Right.
So if you're using the elegoo black, yeah, you can use the light supports. They'll print just great.
Yeah.
But because I'm using Ceria Fast Gray, which comes from that side closer to the middle,
right,
the light support doesn't print as well as the other one. Let's see if I can. I won't let you put support. There it is. It's just too small.
Yeah.
It won't print. So.
Yeah.
And at this point you can. Let's see here. Let's go. Let's just do a quick save. I can delete it. Come on. It's locked up on me, so let me just quit it and get back into it.
Yeah.
Take a second.
Now, there was
box a bit buggy. You just have to restart it.
Yeah.
There it is.
Now, there was a question that came through. Is that just saying that you can move the supports without necessarily deleting a support. I take it just in your process. Do you prefer to just kind of delete one and put one back in, or do you have you moved the supports around?
I've tried. I much prefer just delete and reapply.
Okay.
I know you can move it around, but that's not something that's not part of my process, if you will.
Yeah, and I mean, I think that's part of it is the process, and of course the wonderful cloning of just printing however many you need. So
I'm going to show it here. So we got what? 1, 2, 3, 4, 5, 6, 14, right?
Right.
Right. And can I get more in there? Hold on. What happens if I rotate this?
Let's see how many you can get on there.
Okay, well, this is getting silly.
Yeah.
Yeah, so we're going to have to lose 3.
Think you can probably. It looks like you can get 16. Yeah.
16. Right? So depending on orientation, you can get more or less. Like, who needs 16 CN eyebrows?
Yeah.
That's kind of silly.
But with the planned model that we're actually going to be doing later, this is incredibly useful for what we're doing.
Yeah. So what I'm going to do now is I'm going to slice it,
All right.
and we'll see how long it takes, right?
Yeah.
So for 16 models in a printer, and this is pretty accurate. 2 box is pretty accurate. It says 1 hour 9 minutes.
Yeah. And
so if you wanted to sell these for $5 a shot,
Mm-hmm.
you're making a few bucks at 1 hour 9 minutes.
Yeah.
Now if I go back, remember that 1 hour 9 minutes.
Right.
How much for one? Hey, look, 1 hour 9 minutes.
Exactly the same. Yeah.
Exactly the same.
Whereas a welcome to Steve 87th, who just popped in. Good to have you here. So, but I think you actually raised the point quite well, that with resin printing, with MSLA printing, the amount of time it takes to print one object or a entirely full plate of objects takes exactly the same amount of time. Whereas, as you're demonstrating here on an FDM printer.
So for one on the FDM printer,
mm-hmm.
it's 15 minutes.
Yeah. So it is fast. It is faster.
And then if I go 2, it could be about 30, I bet.
Yeah.
28 minutes.
Yeah. So if you put, we were able to do 16 at the with the other.
Yeah.
And so that kind of gives you an idea of, in terms of the economy of scale, is or at least in printing times, depending upon what you're printing, the speed, like the speed is universally the same speed, but it's the volume that you can print at the same time. So
yeah. So let's get on with the main event here.
All right. So now we're getting into just the process of. Dave and I were talking about what is something that almost every era of model railroading, almost, I have to do that with a caveat, where something that is present on model railroads that's fairly simple to design, and you need lots of them if you have them on your model railroad, and you can't find them, they're difficult to find. And the answer to that, of course, right here, is K-rails or jersey barriers. I understood them. I learned the term jersey barrier. David knows them as K-rails. So this is basically, David is going to take us through the process of designing and preparing K-rails to print right from the get-go. And at the end of this, we are going to make these K-rail models, these jersey barriers, available for you to download and print on your own. And in fact, I'm gonna add a little caveat: is for anybody who downloads these, print them and give us pictures. We want to see you print them. Just as a little bit of interaction. The idea is that it's being designed now, and we want to see how they print out on your printers, if you happen to have them. So, anyway, so David's gonna. Do you want to start explaining your process? This is a great time to start firing out some questions for everybody.
This is how I start everything, right? So okay. let me take you to something a little more applicable to the more difficult models. So one of the resources I use is the Canadian Pacific Historical Society Association. Sorry, and they got a massive. A massive library.
Okay. Now, do you pay for a membership in this place?
No, it's free.
It's free. So
let's call what can we put down there?
Well, I saw a floor plan of a train station there.
Well, here's a 50,000 gallon enclosed water tank.
Mm-hmm.
Right, CPR.
Mm-hmm.
So what we got here are, we have any dimensions? That's what we're looking for, right? We're looking for some sort of reference to how wide this thing is.
Mm-hmm. This one looks a little bit like the one at Heritage Park. Would I be correct with that, or?
I'm not sure.
Okay.
Yeah, so there are actual dimensions on there, and that's what's important.
Mm-hmm.
Because that helps you scale the actual project. So here, I'm looking for Jersey barriers, and I'm looking for something that gives me dimensions, and I prefer metric.
Mm-hmm.
So kind of like this one here, right? Now this has got on the bottom the cutout, but we can modify this to have the these kind of the dual kind of cutouts or no cutouts or whatever. Mm-hmm. So I think this is a nice one.
Mm. Actually,
or just
curiously enough, Brian Ferguson said he was laughing that this is the first thing he's trying to design himself. Is he?
Okay, yeah. Well, we'll get it done for him.
Well.
So I did a print screen. I'm going to go into Paint.
Okay.
Right, and I'm going to crop. This is my method I use. There's probably other ways of doing it.
Mm-hmm.
Because I'm looking at this picture and it looks like it's got a clear backdrop, and that's not good for me.
Right. And of course, because if you drop that in, if it's like that looks like it's a ping file.
Or whatever it is, it doesn't matter now. I got a screenshot.
Yeah.
So there we go. So we're going to save this. Jersey. Okay. So he's saved. So we got our victim. So I'm going to open up CAD. This is a new drawing.
Mm-hmm.
And we're going to go to Insert, Attach,
mm-hmm.
and find the thing we just saved. We called it Jersey, didn't we? There we are.
Now, David, I already know the answer to this question. So do you prepare this like when you make the model? Do you draw it in full size and then scale it down, or you already scale it down? So that's what
I always scale it down,
and that's
it saves me steps later on.
That's what you're about to show us. Now we are going to show how we now then take it from HO down to N scale, or up to O scale, or even potentially up to G scale.
Now, do you think these are centimeters or are these millimeters?
Those are millimeters.
So 3,000 mil.
Yeah, because they.
Okay.
Because some of the Jersey barriers, what is it saying the height is? It's saying it's 610 or 810? Because the measurements that I saw before were about 810 millimeters, which is about.
It says 840 mil.
For height?
Yeah.
Okay. Well, we'll go with that.
Okay.
Because I mean, there are a couple there are a couple of things, but then that 3,000 millimeters. So just for those of you who I'm just yanking out my my calculator here, and that Jersey barrier there is just shy of 10 feet. It's 9.8 feet. That's the 3,000 millimeters is 9. Yeah.
So that sounds right.
Yeah.
So, it wouldn't be 90 feet. It wouldn't be a scale of 10. So.
Yeah, it's basically it's 9 feet 10 inches long. Which and probably that little lip at the end is that still sticks out about 2 inches. So they are roughly 10 feet, but the actual body is the shorter.
Okay, so we got this drawing in here, and obviously it's not to scale. Like, it's not scaled HO, right? So we need to figure out a way to scale this. And what I do is I look for the biggest dimension that's clean that I've got. So the biggest dimension is we got 3,000 mil. So I'm going to take, this is called a work line. It's basically it's just a random line you put in CAD, right? And then from this line, I can easily pull off other lines. You follow me?
Yep.
It's called a work line, right? It's not something we actually use as part of the model. It's just a work line. So what I'm going to do is put a work line from this side beyond, and I always go beyond the attached picture, because then I know it's straight. Right? I do have an ortho tab on the bottom, which is on right now, but this guarantees it's straight. Okay. And then what I'm going to do, so I know where you can see whenever my cursor goes over a line in the background, the little hourglass comes on, right? So we're going to line it up with the edge of the 3000. I'm not too worried about being super precise, but just enough. Right, so now we've got 3,000 millimeters with these two lines. It should be 3,000 millimeters. So I'm going to go work line between the two. Okay? We'll find out what the distance is. The actual distance here is 47,172.1591 mil. So we need this to be 34.443 mil. Right? That's what I calculated on my phone, right? So that's 3,000 divided by 87.1.
Okay.
We can talk significant digits. I just don't care. It makes me feel better if I use like 30 extra digits after the decimal place. Okay. So I'm going to go 34.44 blah, blah, blah.
Okay.
Divided by 47,172.1591. And that gives me 0.000730. So we're going to scale this now. We know what number we need to scale it. So I'm going to put the scale command into AutoCAD, select the object, and it's going to ask you, hey, where do you want to scale from? And then so I selected the corner, and then I put in 0.00073015. That should be enough. Check that's correct. You can see now it's HO scale.
Right.
Compared to the work lines, which we can get rid of now. So now we're in HO scale. Now, there are two ways. Now we need to get the basic shape. Like, we can either make a box, you know, of whatever length, and then cut into it.
Right.
Like that's an actual box right there. We can do that way. Or we can draw lines on this thing. So I do my work line, and then I can draw lines from here to there to there to there. Make them into one kind of surface and then extrude that, right? But I like the method I use is make a box and cut it. I like that method a lot. I use that a lot. So put a work line in, and we're going to draw a box. Now, we're going to make a box. You can't see it, can you? But it's white on white.
Yeah.
But basically, I started the box at the bottom left-hand corner of the item.
Right.
And then I've kind of gone over center, and then I'm going to give it a height of, let's say, 100 millimeters, right? So this is what we got. You have to follow my... So this is what we just drew.
Okay.
It's bigger. It's bigger than the object we're doing, and that's what's important, right?
Okay.
So now we're going to do a whole bunch of slicing. So first off, we're going to slice the top. So we find where the top is, and we slice the top. So now the top is that bit.
Yep.
It goes away.
Okay.
Okay? So I want to make another work line a little farther down. And then we're going to go slice. So we're slicing that block. And I want to go from here to, you know what, I can just go right there. And it's giving us that shape.
Okay.
Right? So now we're going to slice this box from here that shape, and he gets deleted.
Right.
Okay? And now we're going to slice. Well, let's combine them all. So let's union them because, sure. So it's this shape, which doesn't really do us any good. But if we can find out where the halfway point is and then slice it down the middle, mirror it, we've got the full shape.
Right.
Right? So I'm going to go slice here. And it just so happens that my midpoint is pretty close. And we're going to, come on, there it is. That's what we just cut off. And we're left with that shape.
Right.
We're going to mirror it. And then what we're left with is a two-part Jersey barrier that's really, really long.
Yep.
But that's the first step. We've got the general shape, right? So I'm going to delete the other half because there's still more I want to do to this thing.
Right. So the idea is that you're going to work on this half until you're kind of happy with how it looks, and then you're going to mirror it all.
Now, it's not apparent in the drawing, but there are other drawings where these corners are not sharp. They are, I believe, a 2-inch radius. Now, what is that in HO scale? So we're going to go 2 times 25.4. So 2 inches is 50.8 mil. And then we're going to divide that by 87.1. That's a 0.58 radius. We're going to fillet this edge. So radius 0.58. That's pretty big. It might be 0.058. Let me check. Radius 0.058. Yeah, that's it right there.
So it's just a small.
I was off by a factor of 10.
Okay, so a small fillet. And for those of you who don't know, the fillet basically, as you can see there, just rounds the edges. And programs like SketchUp don't have it, but Fusion 360 does.
What I've done is actually went and I filleted all these corners. You follow that?
Yep.
Sorry to cut you off, John.
Oh no, it's okay. Someone just made a comment that it's interesting. It's a different process from Fusion 360, even though Fusion 360 is made by the same people who make AutoCAD.
Now, how long are these barriers? Well, we can look at the drawing. Well, yeah, let's do that. We said 3,000 mil, right?
Yeah. In
real life. So we're gonna change the view. You can see we're now in a sideways view, and I'm gonna do a work line like this. I'm gonna do an offset of what's 3,000 divided by 87.1, 34.44. So this gives us a slicing line. Right here. So we're going to solid slice, dong, da, ding, ding, dong, 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 and this is gone. Right. And so these work lines are gone.
And so now we actually have the proper almost 10-foot length.
Yeah.
There. Now, someone else mentioned that, and a fairly common feature to Jersey barriers today are lift holes. And I don't know if your diagram necessarily. Oh yeah, no, it does. I can see.
It's got a big one, but we're going to make the 2 smaller ones. But we're not going to get there yet because I want to do this trapezoidal. Right. Trapezoidal bit at the end. Yep. Right. And so let's see where we are here. So I'm actually going to slice the model to that shape. So you can't see it. Where's the bloody, there it is. Don't need that work line anymore.
Now, is there a way to make the background diagram slightly transparent?
I don't know.
Okay.
You can make your lines like standard red or something. Like I can go in here. Let's do that. Yeah. And go right click it, go to properties. Yeah. And I say make it red.
Okay, so just so that we can kind of see.
Kind of see it now, right? There it is.
There's
so I wanna slice this now so we can get this recess and the bump out. Okay, so we're gonna slice and dice. You see there's a pattern to this.
Right.
All right, so we're going to slice it. Am I in the right? No, I'm in the wrong. Sorry. You got to make sure you're in the XY plane.
Yeah.
There we go. Or you'll be slicing in the wrong and be like, what's going on? I did that lots.
Yeah.
Okay, so we got that sliced.
How long did it take?
It's just like before. It's just, we're going to come down. We're going to slice from here to here. And yeah.
So how long did it take you to learn to learn AutoCAD?
I'm still learning AutoCAD.
Good point.
I don't know, right? It's it's a big process. So this thing sticks out how much? Doesn't say how long that sticks out. You see what I'm talking about?
Yeah, I see it there. If you can zoom in a little farther, actually, hang on. Let me switch to the zoom to the zoom
I could
window.
figure it out. You know, one way to do it is this, right? So I'm going to do a work line across, and then I'm going to take a line from the edge of our jersey rail, and I'll take a second line from the edge of the bump out. Just zoom in, put a work line between the two, and say what distance it is. And 0.3 mil. So why is that important? Because now we have to slice it again. So come over this side.
Yeah.
And I'm going to go view. And bear with me here. So I want a union. This and this. So we're left with, I don't know if you guys can make that out.
Yeah.
This is the part we want to bump out, right? So one way to do it, which is pretty easy, is I can come and I can slice it. So I'll do it a couple of different ways. So I can go work line, offset, 0.3, this, solid slice here, and then straight over. And this becomes our bump out. So you can actually go ahead and move this in this direction. Let's go. Move here. And then
pop it down on the other side.
Pop it down the other side, and then you've got this part, which should be smaller. We'll take care of that. And then we got this part, which is the part that receives it. But I'm going to show a different way.
Okay.
That, to me, that's too much work. So I can come up here, and I go to home, and then there's this thing, it's called extrude faces. So I can highlight the face, go 0.3, then go to the other side, highlight the face, minus 0.3. Hey, that was much easier.
Yep. and you can just...
and then what I'm going to do is I'm going to come in, we're going to fillet these edges again.
Okay.
Right? And then the other side here.
Now, would you make this side where the bump out is? Would you not just make the fillet? Would you actually make it slightly smaller so that?
Sure, let's do that.
Yeah,
just because when you print it, you want to be able to stack them like the real thing.
Right.
Right. So pretty easily done. It's just a little annoying with that white background. Sorry. Let's go. Let's do a work line here. So we want two work lines. We want one coming from there. Yeah. And then this one's a little trickier because it's along this line. So there. There. Will it give me extension? No. I'm going to copy this line onto itself, like that. And that gives me the reference line. And let's go offset 0.2. Let's do 0.2 mil.
Yeah.
So and then offset.
And this just makes it so that they that when we are lining them up, that this will give it a fairly tight fit. Like on the models that you've done before, I'm just going to make sure that I'm not missing anything in chat. On some of the models that you've done before, of course, you've got pieces that kind of interlock and like little aligning knobs and things like that. When you're oh, there we go.
I subtracted something I should have.
Okay.
Now I want to also slice it.
So
okay.
yeah, like on a standard model kit, you've got like little pins and holes that for pieces to kind of line up. Is there sort of a sweet spot of making something that, like, because if you make them exactly the same, like the hole and what it inserts into the hole exactly the same size, when they print, they're not going to.
That's all experimental, man.
Okay.
Like you've gotta go in and. Is that going the full? It is. Okay, that's what I thought. So I'm just cutting this back here. Sometimes my fingers work faster than my brain to keep up.
Yep.
And this one here is not sliced either. I'm just going around and I'm slicing them off.
Yeah.
Can they still see my face or just my screen?
They can.
Because I just pick my nose, and that I don't know if they can see that.
They can see your face, but I think they're looking at the screen. But I'm not sure if anybody caught that.
Okay, so we're gonna do a fillet right here.
Okay.
Well, let's do a union first, because what I don't want is to create a fillet that goes all the way through and creates a void.
Right.
Right. So let's do a fillet.
Mm-hmm. Mm-hmm.
So that's the male part, and there's the female part.
Mm-hmm. I think you've got.
Just because this is awkward for me, I'm going to rotate everything 90 degrees.
Yeah, go for it. Do what you need to do. Someone claims to have seen you go for your nose. So.
Oh crap! Now I got to kill him. I mean. Okay, so now we're at 90 degrees. Okay.
Now
I screw up my photo.
Steve was making a comment that he was having issues doing designs because Steve, what kind of Apple are you working on? I mean, I'm actually broadcasting from a 2013 iMac. So it's a little older, but it still gets the job done. And I've been using Fusion 360. It seems to work okay. SketchUp does seem to work okay, but part of it depends. I upgraded the memory in this to be able to handle because these programs are memory pigs. So, all right.
Yeah.
And there we go. We've got our
now we want to put those notchy things in, right?
Yes.
So now we got to turn our brains on and figure out how I need to rotate this.
Mm-hmm.
So I can put it up against the...
okay.
So we need to rotate it that way. This is where it can get frustrating, because...
So, like you use the command line a lot with AutoCAD.
Oh, sure.
Mm.
No, I honestly I do it both ways, right?
Okay.
So
okay. Well, I mean,
it's hard for me to tell.
The advantage of doing it as a command line is that it can be it certainly can be much more precise.
Yeah. Okay. So here we have. You see how it's lined up? Let me.
Right.
It's gonna say depends on layer. No, you want. Let's make it green, because now we're in the green phase.
Yeah. So
So you can see how when I rotate it, it now fits just fine.
Right.
So are we going to assume that between here and here, this notch, that's meant for forklift, right?
Mm-hmm.
Is that what that is?
Yeah.
Now, are we looking for? Let's bring up my.
Because it looks. It looks like
which one do we want to do?
Yeah.
Do you want to do this one? Do you want to do this guy here?
You know, it's interesting. The Jersey. Actually, let's put this out to people. The Jersey barriers that I've seen. There's some that have those kind of dual forklift holes in the bottom of them. But some of them also have like lift holes, like where you put a chain or something through and you crane it.
Like this one here.
Yeah, that one right there.
We can do that.
And it looks like the forklift holes line right up with the with the lift holes as well. So.
So what I was thinking is this notch here probably corresponds to that.
Yep.
Like if I were to say, where's my, okay, good. If I were to say slice this, and it would be on this corner here,
mm-hmm.
and then slice this corner here. That's a little disturbing. And then we'll slice.
So the cutout is for...
What do we see? So the holes are right up to the bottom bit.
Yeah. Now there's a note from Brian Ferguson just that some of those... that the holes, even like this, especially this wide one, is not so much for a forklift as it is for drainage. Being out here on the West Coast, some of these Jersey barriers have these enormous drainage holes. Like there are like not all of them do, but some of them have. Like some of them in a long line, there'll be one or two that have every once in a while that are like storm drain size holes. They still do the job of keeping cars on the road if they lose control, but it allows for a lot of the water that falls from the sky out here to pass through. So now Brian did also mention that the cutouts the forklifts do them, but they're not supposed to.
Oh, okay, whatever.
Yeah.
I just want to know how wide do you figure they are?
Well, I mean, like let's go with the measurements there. That the outside measurements there say are
they don't. This thing here?
Well, no. There's measurements across the bottom. That's a 1,200 millimeter width. Where you've drawn.
Oh no, that's not what I'm. I'm talking about the two individual holes. What do you figure?
Right. Brian, since you've kind of done a little research on this, would you be able to give us an idea of approximately where on a given Jersey barrier the holes?
Does that look about right?
The holes does this look about right with what the plan that we're currently working from? Because I mean, we are working from a plan that we downloaded, and I mean, the designs kind of vary a little bit, but. So, chat takes a little bit of time to catch up, but anyway,
So I'm gonna go like that.
Okay.
And this.
Okay.
And needs to be a bit wider.
I don't know if that needs to be. Bring up your other. Bring up the your prototype pictures.
Yeah, they're wider.
Yeah. So okay, so you can just
wider left and right. So
yeah,
what I'm gonna do is actually no, David.
Oh, one thing about doing 3D modeling, I don't know about you, David, but the undo key is my favorite.
Yeah,
my hand hovers over the controller, the Command Z key.
Yeah, I use that lots.
Oh yeah.
So this one. So I'm just moving them apart.
Mm-hmm.
course, there's more than one way to do this too. I can make a box and do a subtract.
Yep.
Fine.
Yep.
How does that look?
It looks. Now some of them are wider. Like some of course have that are just entirely a big gap there, and then some of them, as you can see there.
It's all over the damn place. So we have to.
Right. Yeah, honestly, at this point in time, we just kind of make a choice and go with it. I would say probably just a hair wider.
Yeah. Do it again. That's okay. This is the way it goes.
Yeah. Now Brian was saying he's not so sure on the small cutouts, but he's saying that the big cutout is of 1200 millimeters between is correct of what he was working with.
Okay. But we can't today. We can't do every single.
Oh no. But the idea is that we're just showing how this can be done, because I mean there are jersey barriers that are made of plastic that are filled with water, and their external configuration is slightly different. That looks like they can be, they can be bolted down to the road or something. Like there's these insets into them, and I mean we're doing concrete, so we are not doing that. So.
Sorry, I should be talking about what I'm doing.
Yeah, what
I see in the prototype there's an angle.
Oh, okay.
In this thing, so I'm just gonna make that work.
Okay.
So I made a block that fits the hole.
Right.
Right. I'm just gonna slice this guy. I'm gonna guess. We're gonna go there.
Okay. And I see. And you're gonna shove it back in the hole and then subtract it.
Yes.
Am I correct?
Yeah.
Okay.
Close enough.
Yeah. Steve 87 says that most touches on the forks on a forklift would be about 6 to 8 inches wide. If that helps.
Not really. I appreciate it. I'm just trying to.
Yeah.
My brain is going quick right now.
Yeah.
Trying to get this. Yeah. We have to keep in mind that when this prints, this is what the hell? This is really tiny.
Oh yeah, and I mean it'll be even smaller on N scale.
Yeah. So I'm gonna move this. 50. So it's not wide enough. Okay, so I'm gonna.
Okay.
Bear with me.
Okay.
Make it a bit longer.
Yep. So the idea is what you're doing is you're creating essentially what is negative space.
Yeah, and I'm gonna go make a copy of this. Find the midpoint, which is right there. Match it up to the midpoint. Where are you? There it is.
All right.
Do subtract.
Yeah. And bang.
And no.
Oh!
Got issue. It's okay. Don't panic.
Yep.
There's no nice way of fixing this. I can move them down. Hold on.
Okay.
That should work.
All right.
Where were we talking?
I think sometimes when I'm working with a CAD, occasionally there's every once in a while, especially when I'm learning how to use something, is I lose the model.
Yeah, don't lose the model.
Yeah.
I don't like that. It's not clean as it should be.
Right.
So we're going to do it the proper way. Let this go back up before I moved it. There it is. Let's go.
And you're just doing a basically in SketchUp. This is called a push pull.
Yeah, and just this will be fine. Solid. Subtract.
There you go. There we go. Now we've got.
That's the thing.
Okay.
Now I'm gonna go fillet these edges.
Okay. Now, do you try and fillet most, if not all, of what when you're working on something?
Oh, it depends.
Mm-hmm.
Depends. No, it's so I like to fillet. I should fillet the edges too, right? Because
yeah. Well, I mean, the thing is, when something is cast, I mean, yes, there are sharp edges, but you know, for the most part, they don't. The edges aren't absolutely sharp. I mean, these are small enough that they'll look like fairly sharp edges, particularly when I try to print something like this in N scale. And here we go.
Failed to perform.
Oh,
crap!
Something didn't happen.
Didn't happen. Doesn't like those. Okay, screw it. I'm not going to fight CAD.
Yeah,
that'll be fine.
Yeah.
So we need those holes. Anyone know how big the holes are for the wood chains?
Actually, I think it was on the blueprint. They're listed. Again, Brian, I think you were working on these now.
25 mil.
Now, though that strikes me as a bit small. I've the ones here are, you know, like I mean, 25 millimeter. That, I mean, that's barely a centimeter, and I mean the chains that go through that are much bigger. Actually, go back to the prototype photos. That might give us a good guideline. So. And that can kind of, yeah. I mean, now mind you, those are pretty small. The ones around here are a bit bigger than that.
Well, let's just go to AutoCAD, and we're going to bake it.
Yep.
So what I need to do, I can't I can't draw the cylinder directly there because it's on an angle, right?
Right.
So I need to find something that's flush, like this thing here.
Okay.
Now we can look at it,
and then you can draw your cylinder that way. Brian was saying they're anywhere from 25 to 100 millimeters in width. So
what's 100 by 87? 1 point. 1.15. So go diameter. Yep. 1.15. So that's the that's a 100 mil.
Right. And so you basically take.
That's a bit big. Right? It might look good. Is it halfway up? No, it's closer down.
Yeah.
Okay.
Okay. So Brian was saying that it depends whether or not it's cable versus chain. So, and like I think because we're doing this in both HO and N scale, having larger holes probably would just do us.
That looks really good.
Yeah. So. Yeah. All right. So anyway, there's our holes for it. Now, the ones around here.
No, we need to do the end piece thing because this is great and all, but we need the end piece that slopes.
Yep.
Right. Go ahead.
Actually, David, would you be able to do like a chamfered rim around the around the holes?
Oh, you want?
Yeah, because again, the ones that I've seen, they're not so much filleted as they are chamfered, but filleted will work at this scale anyway. So
yeah. Okay, so now we need to do the one that's on an angle. You know what I'm talking about, the end piece?
Yep, the end pieces. Okay.
Let's find this guy here.
There we are.
Now we can make them that short, and it looks like it's a little bigger than the slot. So let's do a copy.
Okay.
And if we look at the prototype, it's just beyond, right?
Yep.
Right. So, and it looks like might be a bit of a different shape, but it's about there. Okay.
Yeah.
This is where we do about. So we don't have the information.
Right. We're just kind of working with what we have.
This one goes away, and this one, what I want to do is, you'll see why in a sec.
And saying welcome to David Dahlman, who's just joining us. Just for those of you who are joining us, what David is making is a Jersey barrier or a K-rail, depending upon the terminology. Actually, I think one thing that I'm curious for those of you who are in chat, do you know these kind of road barriers as K-rails or as what is it? Jersey barriers is of course the other term, and I think there's another term for the more current designs, and I'm just, unfortunately, that name has just kind of flown out of my head. So what you're seeing David do is, we've just designed a Jersey barrier. Now what he's doing is he's doing the end, basically the end cap. So if you have a long row of Jersey barriers, there's an angled piece that goes at the end of it. So that is what we are working on right now. And once we're done this, then we're going to take the next the next step is to then move it into Chitabox and showing the process of getting it ready to actually print. And at the end of this, the STL file that David is currently designing right now is going to be made available online. For those of you who are watching this in replay, it'll be in the comments section below. I'll post it on my on my Facebook page. David, I'm assuming, because this is your design, you're going to be posting it on yours.
Oh yeah.
And so we're just going to make this available to just publicly available for anybody who is interested in having the
sorry to stop there, John. I got the hole at the front of this. Now this might be from a different series. The holes on the main body look like they're higher up. Right,
and that one's lower down. The ones that I've seen locally, they actually have two holes, but the hole that's closer to the slope is actually offset. It's actually right closer down to that line. So Brian Ferguson is actually coming to us from Ontario, and he says they're called Jersey barriers in Ontario. Or unforgiving concrete blocks.
Should we keep one, or you want to keep the one, or do two?
That one looks like it's going to be. That would be a little thin to print.
Yeah, right here. Look at that.
Yeah, that's going to be too. That's going to be too thin to print. So, you know what? Maybe just do one.
I think right there is going to be where it's going to have to
sit. And then you can I'm assuming you can lose that second hole. So if you're getting rid of that, you would okay, that's you basically just get rid of that. I mean, the nice thing is that this is showing the process, so that when you are actually doing this for your on your own layouts, or if you want to try and do this on your own, you can actually customize it, because there is, these are fairly universal, but there are variations, as you can see from the prototype pictures. That if you wanted to try Brian, you were saying you were designing these on your own. I mean, you're still welcome to do this, but this is one thing that we figured we could do, make this available, because as David will demonstrate a little later, is that once we actually get it into Chitterbox, is to just how many you can just print off for however many you need, rather than scouring a hobby shop for someone who might make these in plastic. And having to buy a bunch of packets. This is one thing where 3D printing shines. And it really works well.
Now, if you see me doing something kind of like, what the heck's Dave doing?
Yeah.
Ask me and I'll let you know.
Okay, so David, what are you doing?
Or I'll just do this and then let you figure it out.
Okay. So.
Yeah, about there.
Now you do have me curious.
All right.
Is this a place where you can place a sign?
Yes.
Okay, because that it just where something is raised, that you can actually put a bit of signage. So you're actually doing a separate barrier that's intended for a sign.
Yeah. Come on.
So.
Not selecting it.
Yeah. So Steve was just remarking, of course, they're referred to as Jersey barriers because they were designed by the New Jersey Department of Transportation and made, but basically open to everybody. And I mean, people have kind of played around with the designs to make them more successful. So. But yeah, I mean, Brian, just as we were kind of contemplating, we wanted to do something that was fairly easy to make, that we could actually make in real time, or not we, David can make in real time. I'm just hosting and yakking to him, and to be able to say, here's an example of something that you can make for your layout, and showing how 3D printing really can improve the look of it and provide you with something that you might not otherwise be able to find. And so that's why this provides it. And there are a number of different variants. You're doing the full sign height here. So
well, I'm making a hole.
Mm-hmm. Yeah.
Should I go to X-ray and show you how that works?
Steve has an interesting question. This might be more above your I don't know is a perfectly legit answer, but AutoCAD, because of the nature of it and how powerful it is, can it determine the center of gravity on an object?
I don't know.
Yeah. So
sorry. I never claimed to be a guru of CAD.
Yeah, well,
I can use.
Yeah, like there are features of AutoCAD that are designed for engineers that can provide that as hobbyists we may or may not have.
So we don't need this reference picture anymore.
Because now that it's done, you've got everything that you need. So. How big of a pole or wire, or would you put brass tube in there, or would you actually print something to go in?
I have it at 0.6 mil.
Okay.
So whatever you can, it doesn't go all the way down. It just goes about 2 mil.
Okay.
You just drill it out for whatever you need.
Yep.
So that's that's the jersey.
All right. So,
Jersey barrier.
All right. So we've got our jersey barriers, and the idea is that we can print as many of these as we need.
All right. So now to print them, we have options, right?
Yeah.
We can do. I would print these flat on the build plate.
Okay.
There's no reason you shouldn't be able to print it flat. You'll have a little elephant's foot along this edge.
Mm-hmm.
But because I've come and turned down that edge, it won't be so bad.
Mm-hmm.
But if you put it on supports, you can probably support it from the top or the bottom, but it won't print as nice. So I would go flat on the build plate here.
Okay. That you would just take them and you just put them straight on the build plate and just print them off. So
so I'll make a few variations here.
Yeah.
So what I like to do is I just do copy.
Mm-hmm.
And it's going to go slice it.
Okay.
Right. So if you want that one.
Yep. Okay. All right. So some variants there.
And if you want one with no holes.
Cool.
So I like doing the base one and then coming back and
doing your variants. And for the end piece, I think you've got it set up so that it like there would be end pieces on either end. One would have an inset and one would have would be out. So
but this it doesn't matter.
Oh,
right?
Okay. Since inset,
you've got this will fit either end.
Yeah. So no, that's certainly that's fine. I couldn't remember if that one was sticking out or not. So. So Steve is asking, would you that you would say straight on the build plate of a resin printer?
Yeah.
So
or FDM, either way, build plate.
Yeah.
So this is essentially. Let me actually save this.
Mm-hmm.
So that's. I've got a scenery folder.
Mm-hmm.
Scenery stuff. I'm going to call this jersey.
Okay.
All right. So now we can start exporting this.
All right.
So let's do the original ones that we designed. Where's the J's? Well, we want scenery stuffs. And there's no... Oh, I see. It won't let me do the folder. Okay, let's go... Then we have to figure out a name scheme, right? So let's go jersey.
Yep.
And let's go center.
Mm-hmm.
2 holes and forks.
Okay.
And that's that one.
Right.
Right? So let's do another one here. So we take the jersey one again. We're going to go long fork.
Mm-hmm.
Right? And then we'll do another one. Jersey.
No holes.
No holes. Forks.
Okay.
Let's go jersey, 2 holes, forks, and we call this mast. That one.
Okay. And you call it mast because it has the for the signage.
Yeah, and then jersey end.
Okay.
And I wouldn't mind doing a. Well, I would take the mount.
Right.
And I would put one right there.
Okay.
But not right now.
Okay.
My brain hurts a little bit.
Yeah.
So I'm gonna close out AutoCAD.
Yep.
And so let's go into, let's close this down so we're not using it. Hey, girls.
Mm-hmm.
Shitbox.
Okay.
Here's our build plate. Go to documents, Scenery stuff. Hey, look, right here.
Right.
So this is the center one. So this is the, oh, look at that. It's 90 degrees.
Right.
So just going to bring it up. And I don't know if you can see those numbers there, but it should either be 0, 270, 90, or whatever, right? So that's it.
Yep.
Now, if you wanted to support it, you could support it, but I don't know why you'd want to support this. And how many do you figure? Let's take a guessing game.
Okay.
How many do you figure we can put in a build plate?
All right. Any guesses on how many we can actually stuff onto this build plate? I'm sitting here.
We'll do the first two. We need the first person with a number, and then the second person can do higher or lower.
Yep. Okay. So we just need a number. Shout it out in chat if you've got it. My guess is I said my guess was 12, and Steve said 12. So
12, eh?
Yep.
Is that a challenge?
Well.
Yeah. Okay. I can beat 12.
Oh, I'm sure you can beat 12. There we go. Somebody else put 34. Let's. Okay. Wow.
18.
18.
No, it's not. I can't count. 1, 2, 3, 4, 5. 21.
21. Okay.
I would like them a little farther apart.
Yeah.
Yeah, so 21. Okay. That'll print beautifully.
All right. So there we go. Now you, and how long will this take to? And this is HO scale.
This is whole scale. So guys, how long is it going to take to print 21 jersey barriers with 2 holes? We need a number in minutes. The closest number wins an open observation. Just kidding.
You know what? I'm gonna guess at that height. I would say probably 120 odd minutes.
2 hours, eh?
That's my guess. But
we need someone to guess.
Anybody else got a guess as to how long that will print? So someone else, we got a 74-minute guess, 80 minutes. I'm saying 120.
55 minutes, 18 seconds.
Off by an hour.
Did everyone overbid?
One person actually, Brian put in sort of last minute, put in 50, so he was the only one under.
Okay.
So
that's 55 minutes, 18 seconds. So let's replace it with the end piece.
Okay.
So 55 minutes, 18 seconds.
Yeah.
How long for the end piece to print? Any guesses?
Well, my guess is exactly the same amount of time because it's the same height.
55 minutes, 18 seconds.
Yeah. The one that will take longer is the one that has that little extra bracket on the top of it for science.
You can see here the layers going up.
Yep.
50 layers per millimeter.
Yep.
Go back.
Mm-hmm.
Let's do the one with the bracket. They call me Mr. Mast. Mm-hmm. So that'll render. Look at that. This will render beautifully. Mm-hmm. 58 seconds. So it's an extra. How many extra layers is it?
Let's see.
So 193 is a regular 94. So it's 3 extra layers.
Okay. So it's still fairly tight. And for those of us who are N scalers, do you want to just show how easy it is to now take this and put this down to N scale?
Okay, so let's go back to the original one.
All right.
We want the 2 forks. Let's always want to align this properly on the build plate, right?
Yep.
So, 90. So what's your magic ratio, John?
54.5. There we go.
Now we need more guesses. How many will fit on the build plate?
Well, it'll take about half the time, but let's try 40.
You want 40? Any other guesses out there? I think it's going to be so many it'll crash my Chichu box program.
It's entirely possible. So, now what version of Chitterbox are you running?
1.5.
Okay, yeah, because I've got 1.7, and I know that some of the versions are like I 1.7 is a stable.
Sorry, I find this very amusing.
Wow. How many is that?
63.
63. Okay, so Steve. Well, there's your highway barriers in one print.
Okay, how long, John? How long do you figure?
To print, the last one was 55 and change. I'm probably going to say 35.
Okay, so let's play a different game here. So we got 63. So let's say John decided that he needed 63 jersey barriers for his layout. Can you find out how much these would cost at Trains and Such, or your local hobby store, Central Hobbies, or what do you figure?
Give me a second.
What does BLMA charge for? And then we'll look at your cost.
Now these ones appear to be longer, and $6.95 for a package of 12.
$6.95 for 12.
For 12.
So $6.90. That's American, right?
Yes.
So we're talking 8 Canadian divided by 12. So they're 66.6 cents each times 63. So you're looking at 42 bucks.
Mm-hmm.
What do you think the cost is in resin?
I'd be curious I would be surprised if it was over $1.
All right. So according to this, 38 cents.
Mm-hmm. So
35 minutes to print and 38 cents.
Mm-hmm. And all of a sudden you have as many jersey barriers as you need. And again, Dave designed this in HO scale, and was just simply a couple key clicks, and all of a sudden we've got N scale jersey barriers. For those of you in O scale and larger, we can go the other. We can definitely go the other way too. Of course, something bigger and taller will take longer print. If we're doing this, if for whatever reason we decide to do this in G scale, a G scale jersey barrier might not fit in this. I would be curious. So 38 cents for 65 jersey barriers. Wow.
I'm just going to mock up in this program here.
Mm-hmm.
Just put a couple together to see what they would look like.
So, I see what you're doing here is to actually kind of show them lined up.
Yeah.
I mean, because if you really wanted to, you could actually like stick a bunch of these together and actually print them together as one piece.
Yeah, I'll show that here in a second.
Yeah, okay.
No. Is that David? No. What have I done? No. There we go. It's like I'm building like a...
Mm-hmm. Now, of course, that goes off the end just a little bit, but that there gives you an idea of.
So if I wanted to say, I like this, I just want to print off these three over and over again, I can actually save it.
Yeah.
It's a Jersey 3. Okay, now I can delete it.
Yeah, and then
open it up as a Jersey 3.
Mm-hmm. So the idea is that you can actually. So for example, in the way that the files are presently designed, they kind of land 90 degrees. So you can actually rotate them 90 degrees, and then just resave them, and have them the way that that you would want them.
Yeah.
Very cool.
I don't like that. So
yeah.
we're gonna delete that Jersey 3. He's not very nice.
Yeah.
Yeah. So that's it.
Cool.
So that's what our goal was tonight to get done.
All right. So and of course we've got your tunnel portals there. So
that's the Kanawha Tunnel. That's the eastern portal of the Kanawha Tunnel.
Yeah. The
wings are just askew, and that's for Nathan.
Okay. Now, are you printing that in? I know you showed that last time that. Are you printing, like slicing that one up and printing it in resin, or?
Oh yeah, there's too much details for it to be FDM.
Okay. Yeah.
This is not an FDM print.
Right.
Definitely, because there's lots of.
Yeah.
Here, there's.
Yeah. A lot of those extra bits and pieces. Well,
yeah.
David, thank you for doing that. I realize we are coming up on actually almost like I realized last time we went for 2 hours and 8 minutes, but this was the goal, to actually show the process from beginning to end. And I mean, what David just showed is the step just before you put it on your thumb drive and take it down and plug it into the printer. So those files are basically as soon as we get them posted, and if you're interested, there's my Facebook page will point it to the Thingiverse page for public. But if you're already on David's Ninja page.
Ninja.
His private Ninja page. Chances are the files will be there first.
Okay, well, hold on a sec. Hold my beer.
Okay. Because if you can email me those files, I'll put them up to Thingiverse, but I won't be able to get them up until after my son goes to bed in about an hour.
Oh no.
Yeah. So
where did I put these things? I put them here. Just bear with me here.
Not a problem.
You can't see my screen anymore, can you?
No, it's just your face at this point. So don't worry. Do what you need. Do what you need to do. Oh,
here we go.
Okay.
So I'm trying to find. We put them in scenery stuff. Right, and then we put them in Jersey. They're in the zip folder now.
Alrighty.
And then I go to Upload Compete.
Okay.
And if someone can go into my Google Drive, please, and tell me if it's there.
All right. So I have to check to see if I've got your Google Drive. So
I I can send it to you.
Yep, just
email.
If you can just email it, if you can email it to me, I'm just checking my.
Can you type your email in the messenger for me?
Sure. Just doing that right now. So. Yep. There we go. All right. So sent to you, and
I think I got that right.
Okay. All right.
Attach desktop.
Oh yeah, and Brian, I think Brian, you do make a point that yes, there's a lot of when it comes to 3D printing, there's a whole lot out there for people who do fantasy prints, and I happen to follow it because somewhere here I've got the from my latest D&D game just this past Saturday, so I'm very familiar with that. Things like Hero Forge and the like that you can print off. Now, actually, one thing that Eric is here. That he can place the link in the video notes when done. One of the things that in the comment section, and I'll also add that in the comment section just so that things are properly linked to where they need to be, and we can make sure that everybody gets access to this. I've
lost my Zoom. I don't know where it went.
Oh, well, it's hiding behind something because I can see you, and if I can see you, everybody else can see you. Although they can see me twice in reverse.
Huh.
I suddenly realized that they're seeing my live feed, which is this one, and then the other one kind of waves in behind. So they're getting me in stereo.
Could someone check the Google Drive to see if it's there? Would it be possible?
All right. Now, let's see. So now you shared it. You shared it with my email address.
Yeah, you should have the email already.
Okay, I just have to switch over to. I've got a dozen different email addresses. Shared with me. Okay. I don't, Dave. I don't see it yet with my JC's RipTrack one yet. Let me do a reload on this. Now, did you email it to me or just I
emailed it to you.
Emailed. Okay. Well, then that's why I don't see it. So let me just pull up my Gmail. Yep, there it is. It has arrived. So I will unzip it so that when I post it up to Thingiverse, you can actually see the individual files because it'll do that kind of blue render thing.
Yeah.
So now the files you've sent to me are specifically in HO scale, and I will. I can do one of two things. I can load it into Chitterbox, shrink it down, and then do a separate N scale batch, or the first batch will be HO scale, and then you could scale it down yourself, and I'll even put that in the notes. Or I'll run it through Chitterbox and shrink it down and set it up to people. If that is okay with you, as you are the creator.
Fine, works for me.
All right, so that works well. I'm just going to bring up the chat window because I think we're just getting to the point of The reason that the one on the left is slower, the one that's right above David, is that's actually from the Zoom feed, whereas the one you're actually getting from me up in the corner is the one we set up because we noticed that there was a delay last time. And so this is me directly on the computer, whereas the other one is showing the Zoom chat. Normally, that's not where my picture would go. So it's adding this little bit of, I can go like this, and then the other one will do it just shortly later. So anyway, that's kind of fun. Anyway, we have these we have these now, and so in the next couple of hours, you will see these posted up, and I'm gonna share these to my Facebook page. David, I'm assuming that you're gonna get the jump on me. You could go post these right away and
already up.
And scoop me. So for those of you on Facebook, they're already there. Anyway,
awesome.
I realize we are now almost exactly 2 hours in. This was exactly what we were kind of hoping to do, just as a quick way of doing it. And the last challenge for everybody here, and I'm going to repeat this, I would like to see you post pictures of your Jersey Barrier prints. I'm going to take these and I'm going to do mine in N scale and show how they work in mine. And I may even do, can I fill a plate of these?
Oh, shit. I mean, shoot.
Maybe. So I wouldn't worry about that. I think PG-13, we get one of those. So we're okay. Anyway, so again, thank you everybody so much for doing this. David, thank you so much for showing this on the fly. For everybody else, enjoy the free models that are coming out of this, and we will catch you the next time we get together. So the Facebook group name for David is a private one. So the way you do that is you email me, and I'm just going to put my my email address into the chat. And I'll flip that over to David. But it's a private Facebook group that David needs to invite you into.
So they can apply.
And so it's called Dave's. I'm sorry, I'm blanking on the full title because it involves Dave's and Ninja. There we go. There are Dave's Canadian Pacific Model Railroad 3D printing. Didn't the word ninja?
Ninja World.
Ninja. Sorry, Ninja World. Okay. And just do a search on that, and then David can let you in. That way you get direct access to David. I am going to post them on Thingiverse, but like I said, it's going to take me a couple of hours because I've got to get my son settled to bed. And everything else with that, and we're going to get that up. And once those links are up, I will post them to my Facebook page as well as in the comments section below on this, so that you can get direct access to your own Jersey Barriers and print as many as you need to.
And we should ask them how often they want these.
Yeah, actually,
what do you call this? Live stream. Yeah.
That is a good point. Is like we do have certain room in our schedule to do this kind of talking about 3D printing. I mean, I'm still going to be doing my weathering videos as well, but these live streams are things that we like to do. This is actually David's day off, and Mondays happen to be my day off. So we can do this every couple of weeks, and maybe one thing that we could do is have people kind of submit how would we go about and do a design on something. So think about that, put it in the comments section below, and give us an idea of what you'd like to see, and we're going to post that question more broadly to some of the other Facebook groups that are out there. But with that, I think we need to bring this to a close. And,
2 hours. That's pretty good.
Yeah, and thank you for doing that. Now, Eric just sent me a picture. So
is it the stream still going, or I can't tell?
He actually Eric Hall just sent me a. Just sent me a picture. Oh, where are we here? Let me bring myself to full screen. That I can actually just show on my phone where Eric has actually already downloaded them and set them up in his slicing program. So that's how quick.
Wow.
And really getting this all set to do this. So again, thank you so much, David, and for all of this and for this process. And the other thing is David, you had mentioned about perhaps getting some other people in the conversation as we're kind of working on that. That's something that we're going to work on. About
peanut gallery
to add in to indeed add in a peanut gallery, and we can do this through Zoom and then broadcast it out to everybody. I'm just going to transition back so we actually have David instead of just my face. And actually, sorry, the pictures that Eric showed, those are actually ones that Eric did himself. And I think he's so this shows you the kind of universality about that. My apologies, Eric, on that, but it's interesting to kind of compare and design for those. So there's a request for monthly. Maybe we can try and do that. And so, David, I will be talking to you offline, and we'll see everybody on. We'll see everybody on Facebook and perhaps for our next live stream. So so I'm gonna end the stream now. But David, if you want to just kind of stick around for just a little bit, and then we'll go from there. So again, thank you very much, everybody, and